All right, these are the answers to page 304, which is the U sub work. And so when you do a U sub, you're always looking for a function that's inside of another. That function that's inside is going to be our U. So this x cubed plus 5, that's what we're going to make the U. Then we take the derivative, which will be 3x squared dx. And then if we divide that over, then dx will be du divided by 3x squared. Okay. Now we're ready to do our substitution. This will be x squared times x cubed plus 5, that we made u, to the 4th power, times dx, which we're saying is du over 3x squared. Two good things happen. This x squared cancels with the x squared. We want that to happen. We need the x to go away. Okay. And we have this third, which we can pull out front. We'll just make this a 1/3. Okay. All right. Now we didn't know how to integrate this. This was way too complicated, but this is much simpler. That will integrate into u to the 5th over 5 plus c. And we're almost done. The last thing we're going to do is bring back the x, because this was in terms of x. To give an answer in terms of u is a little silly, right? That wasn't what we wanted. We wanted something in terms of x. So multiply this 3, 5, we'll get 1/15 times x cubed plus 5 to the 5th power plus c. That would be our answer then. Okay. Same thing, 25. I see this 1 plus 1 over t, that's inside of the cube. So u is going to be 1 plus 1 over t. So that means du will be the derivative of 1, which is 0. Derivative of that would be negative 1 times t to the negative 2 times dt. Okay. Now, another way of writing that would be negative 1 over t squared dt. So if I were to multiply by t squared and divide by negative 1, I get negative t squared du equals dt. Okay. Again, there's other ways to have that, but that's probably the easiest in terms of then seeing what happens. So now I come back over here. I have the integral of 1 plus 1 over t. That's u cubed times 1 over t squared times dt, which is negative t squared du. T squareds cancel. I've got a negative, which can come up front. I'm integrating u cubed. That's going to go to u to the 4th over 4, and then plus c. So what I did was I took that negative out, and then I said, what would I have left? I'd have u cubed du. So when I integrate that, that goes up to u to the 4th over 4. Almost there. Don't forget to put this back in, this 1 plus 1 over t to the 4th over 4, and then plus c. Once you get the hang of it, these u subs aren't too bad. On this one, I see I've got x squared inside a cosine, so that's going to be my u. So if I brought this dx over and then I integrated both sides, what I'd end up with is y equal, and I need to integrate. So I'm going to let u equal x squared. Du will be 2x dx, which means dx will be du over 2x. And this is going to give me the integral of x times cosine u times du over 2x. X's cancel. I can bring the 1/2 out, cosine u du. And then if I integrate cosine, I get sine plus c. Now, here's the deal. We're going to do two things. One, we're going to bring x squared back. But we're also going to try to figure out what c equals. So when x is 0, c or y is 1. So I'm going to put 1 in here. Sine of 0 is 0. So this becomes 0 plus c. So the c value ends up being 1. Almost there. Here's our equation then. And this really is a sneak peek at what we're going to be doing in chapter 7. Or I'm sorry, chapter 6. So don't get too panicked if that seemed a little weird. I was just giving you a little, like I said, preview of what we'll be doing later. Here I've got 2x inside of sine. Now it might be easier for you just to kind of go backwards inside it. You see, you know sine's going to go to cosine. You know that it'll be negative because the derivative of cosine is negative sine. So we know that has to be negative. We know the 2x is going to stay inside of it. And if I were to take the derivative of this, it would go negative sine. Negative would cancel, give me back here. I'd leave the inside alone, but then I would have to go times the derivative of the inside, which is 2. So a 2 is going to kind of pop out of here, and I don't want that 2 to be in the answer. So in order to neutralize that or cancel that, I would need a 1/2 there. Now, some of you will like doing it that way, just kind of thinking about what do I need to take the derivative of to get to here. And that might save you a little bit of time. Others of us make u equal to 2x. du would be 2 dx. So dx would be du over 2. And then you get the sine of u times du over 2, which integrates to negative cosine u, actually negative 1/2 cosine u plus c. Put the 2x back in, we get the exact same answer. Choice is yours. On 49, though, this one's a little goofy because we got the sine and the cosine. And so this one actually, and if you got a little stumped on this one, I don't blame you. What we're going to do is we're actually going to let our u be sine x, sine 2x. Because the derivative of that is cosine 2x times 2, which means dx will be du over 2 cosine 2x. Right? When you come back over, then it's going to be the integral of u times cosine 2x times dx, which is du over 2 cosine 2x. The cosine 2x's cancel. We bring the 1/2 out. And this is what we're looking at. 1/2 times the integral of u du, which is going to be 1/2 u squared over 2 plus c. That'll give us 1/4 times sine 2x squared plus c. Bring that sine 2x back in for the u. Right, definitely a little bit of a crazy one. This one's a little crazy too. The 1 minus x is obviously our u, so, because it's inside of the square root. So I'm going to make 1 minus x equal to that. Du then will be a negative dx. And when we go to do our substitution, we're not going to have anything to cancel the x squared, and that's a problem. I can't integrate with two different variables there, at least not in this class we can't. So what that means is that we're going to have to replace the x with something else. And the easiest way to do that is to come back over here and solve this now for x. So if I were to add x and subtract u, then x is equal to 1 minus u. Now this doesn't pop up very often, but in the particular, if for some reason you can't get your variable to cancel, then you'd have to do this as well. So 1 minus u squared times the square root of u times a negative du. Okay, I put u in for 1 minus x. I put 1 minus u in for x here because it didn't cancel with the substitutions. And then I have this. So again, from here, and I know this is obnoxious, we have to FOIL this. And you're going to love this next part. I'm going to pull the negative out front here. We're going to distribute this square root of u to everything. So I get u to the 1/2 minus 2u to the 3/2 minus u to the 5/2. I'm just giving square root of u, 1/2 u to all of these, okay? du. And then I'm ready to integrate. So this is going to integrate to u to the 3/2 over 3/2 minus 2u to the 5/2 over 5/2 minus u to the 7/2 over 7/2 plus c. And we're not quite done. What we're going to do is simplify this a little bit, and we're going to bring back that 1 minus x. So final answer, I'm going to flip this 2 3/2, make it a negative, negative 2/3 times 1 minus x to the 3/2. Okay. Then I'm going to bring this negative here. That'll become positive. 2/5 or 5/2 flips becomes 2/5 times 2. That's going to be a 4/5. 1 minus x to the 5/2. Okay. Then the negative and negative cancel. This flips over, becomes 2/7. 1 minus x to the 7/2. And then plus c. Holy crap. That is a lot of work. Will I see something like that on the AP? Thank God, no, you won't. But if you could do something like that, then the rest of these things tend to become a little simpler. 72. Our u is x cubed plus 8. du is 3x squared dx. So dx will be du over 3x squared. Now, when you come over here and you do the substitution, okay, the x squareds are going to cancel. That's nice. But now we're going to be moving this into terms of u. And what we want to do is we want to change then these limits. It's going to be a whole lot easier if we stay in terms of u and just solve it here than if we try to go back to terms of x. You can, but it's we're just going to save ourselves some time. And sometimes the AP forces us into this idea. So in other words, this -2 and 4, these are what I call x limits. This is when x equaled -2 and x equaled 4. Well, if I put -2 in here, I get -8 plus 8, which is 0. That's a u limit now. If I put 4 in here, I get 64 plus 8. That's 72. That's my u limit now. And what I can do is, now that the x's are gone, I can just evaluate this. I never have to go back to x again, okay? So I go ahead, I bring this 1/3 out. I'm going to integrate u squared. That's u cubed over 3. And we're going to evaluate that from 0 to 72. And so when we do that, I'm going to get 1/9 times 72 to the 3rd power minus 1/9 times 0 to the 3rd power, which is 0. I'm going to end up with that as my answer. And that's something very large. If you want to put it on a calculator, God bless you, but I'm just going to leave it like that. And the final one, again, we're going to evaluate this. 2 sine x evaluates to 2 negative cosine x. If I take the derivative of cosine, it's negative sine. That would cancel the negative, get me right back to here, okay? And again, you may want to just kind of mess around with this one until you start getting good at just writing out what would it be. If I took the derivative of cosine, it'd be negative, so that would cancel that. It would be sine 2x and then times 2 from chain rule. That 2 would cancel this 1/2. It would put us right there. Okay. Now we're going to evaluate. Let's put pi in. I'm going to get -2 cosine pi minus 1/2 cosine 2 pi minus 2 cosine 0 minus 1/2 cosine 0. All right. The cosine of pi is -1. -2 times -1 is 2. Cosine 2 pi is 1. So this would be 1/2 times 1, just 1/2. There's our top. Cosine of 0 is 1. So this is going to be 2. And cosine 0 is 1. All right. So I get 2 minus 1/2 minus 2 minus 1/2. That's going to equal 0.